Hey everybody, this week's lesson, describing data. All right, so here's your note slide. We've got a lot of new vocabulary this week because when we are asking you to describe data, you have to say particular data words, okay? So I know it looks like a lot, I'm sorry, but they're really easy, and then I'll get to show you the pictures that go with them. It's gonna make a lot more sense, okay? So our first word is range. Now you've seen this word already, but I'm gonna change it up on you this week. The range is the difference between your minimum and maximum values, okay? So we used to say lowest number and highest number. We're going to change that up and get you ready for the next coming or the coming up lessons. And we're going to call them minimum and maximum now, okay? A cluster is exactly what you think it is. A cluster is a group of data sets that are close to one another. And in the pictures that are coming up, you'll see. A peak, think of a mountain where one or more values have a higher frequency than the others. Gap is where you've got some empty spaces where there is no data. An outlier is a value that lies outside or is much smaller or larger than most of the other values in a data set. Symmetrical is where if your left and right sides of your graph are mirror images of each other. And then we've got this word called skewness, is when your data tends to have a long tail on one side or the other, and it can be skewed two different ways. It can be skewed left, where your tail is on the left side, or your left side is longer, or your data can be skewed right, where your tail is on the right side, or your right side is longer. And then our last word of the week is uniform, and that is where your data is spread equally, okay? So go ahead and pause and get your notes taken down. If not, if you want to look at the examples, then write your notes at the same time together. Each of these definitions is also going to be on the upcoming slides, okay? All right, so our first word is a word you already know, but I changed things on you just for to prepare you for our next coming up weeks. Our range is the difference between your minimum and maximum values, okay? So your minimum is now your low number, or what we were calling your lowest number in the past, and your maximum is your highest value, and now we're going to call them minimum and maximum. So this guy is your minimum because it's your lowest value in your data distribution or in your data set, and this guy is your maximum. Okay, and you're just going to do the same thing. You're going to take your high number, which is your maximum, minus your low number, which is your minimum. Don't forget to borrow. And your range is going to be 9. Okay, so same thing, different words. Get used to the different words. Next word, we've got cluster. Cluster is a group of data points close to one another. So if you look at this data shape, this data distribution, you'll notice that we've got a couple of guys hanging out here, and then we've got this big group of dots that are all hanging out together, okay? That's going to be a cluster. So we've got a cluster at around the 35 or 34 to 36-ish, okay? So we've got a cluster of data right there. Next one, peak. Peak, think of like a mountaintop, okay? And I picked this example so that you could really see, you can really pick it out of here. So peak is where one or more values has a higher frequency than others. So we've got, really low numbers, 1, 1, 1, 2, 2, 2, 2, and then boom, it shoots up to 4, and then bam, back down to 1, okay? So think of your peak like a mountaintop, or in what we've been doing the last few weeks, think of peak as your mode, okay? And you can have more than one peak, you can have more than one mode. In this example, I just picked it out for you because it was like so obvious, okay? So your peak is where you've got one or more values at a higher frequency. Think mode. Mode most, peak highest, okay? Next word is, hello. Next word is a gap, and I think you know what gaps are, but on a data, on a graph, you can see that we have gaps here. Gaps are your empty spaces where there's no data. So we've got a gap right here between 325 and 375. And then we've got another gap here between 400 and 450. So a gap is where there is empty space with no data. This graph has two sections or two gaps in it, okay? All right, our outlier. This is one of my favorite guys, and this one's pretty easy. Your outlier is a value that lies outside or is much smaller or much larger than most of the other values in a data set. I always call the outlier, I call this guy the outsider. He's kind of way away from the pack. He's way away from everybody else. So he's your outsider or your outlier. In this graph, your outlier is this guy over here. Okay, he's way away from the rest of the group, especially this cluster here. Okay, he's way out here at 15. These guys are down here at like 35 and 40. Okay, our outlier on this one is this guy out here on the end. He is much larger than the rest of them. So he's out here at 10, and all these other guys over here are down at like 4 and below, especially we've got a whole bunch at 0. Okay, so your outlier, think outsider, is way outside your graph, way outside of the most of the other values, okay? So your outlier is actually going to have a huge effect on your data. It's going to have a huge effect on like your average or your mean, because it's gonna mess with your numbers, okay? So think of like if we've got test scores and a bunch of people score really low, and then we've got one person that scores really high. It's actually this one person's high score is going to affect how that data really looks for the whole class. Does that make sense? So your outlier is way off, and he's going to affect your data, especially your like your mean, your average. Okay, the last portion that we're going to talk about is the shape of your data or the shape of your data distribution. And this one's easy as long as you take your pencil or pen and you kind of trace over what your graph looks like, okay? So your first one is symmetrical, and that's where if your left and right sides of the graph are mirror images of each other. So if you take your pen or pencil and you kind of trace over the shape of your data, okay, and this one, it kind of looks like a mountain or like a bell, you know, and if you were to draw a line down the center and fold this data in half, it would look the same on both sides, okay? Same thing here. Just lightly trace your data, and when you draw a line down the center, your sides should match, okay? Kind of like if you were to take a piece of paper and put some paint in the center of it and then fold your paper in half and then undo your paper, you would end up with the same design on both sides, okay? That is symmetrical. Kind of like how our bodies are symmetrical. We've got a left and a right hand. We've got a left and a right leg, okay? They're the same on both sides. All right, uniform is where your data is spread equally, okay? So if you take your pencil or pen and you just kind of draw a line above your data, it's gonna be flat for uniform because all of this stuff is about the same. Notice, you know, this guy's a little bit low, but for the most part, everybody stays within the same range. So your data is spread equally. This is uniform. You're gonna have a straight line above the top. Okay. Then we have two types of skewness. We've got skewed left and we've got skewed right. Now this one is real easy to see if you take your pencil or pen and you trace your data. This one kind of looks like that you're going, like you're starting a roller coaster, okay? Your tail is over here on the left, and so that means your data is going to be skewed left. Remember, this is your left, this is your right. So it's kind of like being on a roller coaster, like you're just getting on the roller coaster and you're going up and then you're coming down. So that is going to be skewed left. Skewed right is just the opposite. This is where you're like, say, on the last big dip on a roller coaster and you're coming on down, and that's your last part where your tail is over here. Right here you are on the roller coaster and you're coming down, whee, and we're stopping. Ride is over, your tail is on the right. We've got skewed right, okay? All right, now what I'm gonna do is I'm gonna go through a few examples and we're gonna describe the data, because this is what you're gonna be doing on your performance task. You're gonna be looking at a graph and you're gonna be describing it to me, but you have to use the specific words that we learned today, okay? So on this first one, if you take your pencil or pen and you trace over the data, okay, you're going to see that it is skewed right because your tail is on the right. Remember, this is your left, This is your right. So we've got data that is skewed right. And usually I start off with the shape because it's easy. So skewed right. Looks like we've got some gaps here. We've got gaps at 3, or gaps at 2 to 4, and gaps at 6 to 10. Okay, so we've got some holes right there. It looks like we have an outlier. Yep, we've got an outlier at 10 because he's way out here. This guy, he's my outlier. Okay, do we have any clusters? Yep, I'd say we have pretty big cluster here and a cluster here. So clusters at 0 to 2 and 4 to 6. Okay, and do we have a peak in this data? Yes, we do. Our peak is at 1 because this is our tallest, this is our mode. Okay, so we've got a peak at 1, and I think that covers that one. Okay, let's look at this next one. Whoops, I didn't mean to draw a line on our graph right there. Okay, so let's look at our next one. All right, do we have a shape here? Yes. Let's trace our shape. Let's go up like this and then down here. And this one kind of looks like a mountaintop or a bell. And if I were to draw that line down the center, we would have a symmetrical shape. Okay, so we're symmetrical. I don't see any gaps. I don't see any outliers. So no gaps or outliers. We've got a pretty good cluster here. We've got a cluster at, I don't know, 21 to 23. And do we have a peak? Yep, we've got a peak at 22. And I think that covers that guy. All right, 2 more and we're done. Okay, look at this guy. If I were to just trace my data, it would look like that. And honestly, if I were to draw that line down the center, it would be symmetrical. Our data distribution or our shape is very spread out, but it still would look symmetrical in my opinion. We've got numerous gaps, and I'm not going to go into detail. You guys will have to go into detail on your performance task and tell me where those gaps are, but I'm going to run out of time if I write those all down. So I've got a bunch of gaps here and here and here. I've got a huge gap here. I've got a couple of outliers on this one. We've got an outlier at 40 and 16. We've got a peak at 31. Okay, we got a peak at 31. Am I missing anything else? Let me look at my other slide. Am I leaving anything out? Peak, cluster, outlier, gaps, skewed right. Do we have any clusters? A little bit of a cluster here, yeah. So we've got a cluster between 30 and 32. Okay, and let's look at this last guy. Our data is pretty much uniform. Okay, it's pretty much staying the same. Uniform. Pretty much when they all look like that, I would say our whole graph looks like a cluster, so definitely clusters. Outliers, no. So no outliers, no gaps. We've got some peaks here. We've actually got these guys, 1, 2, 3, 4. We've got a bunch of peaks here. So we've got peaks or modes, numerous. Okay, now on your performance task, please be specific and tell me where they're at. I am about out of time on this video. Okay, so uniform, no outliers or gaps, peaks. Our graph is pretty much a whole cluster of data. And am I leaving anything out? I don't think so. All right, so just in time, please rewatch this video if you need to so that you can do an awesome job on your activities and your performance task. Have a wonderful week, and I will talk to you later. Miss you bunches. Bye-bye.